Hello, welcome to ANS Solver. This is the seventh question of the paper. So in the part 1, we need to find the exact gradient of the curve for which the point is theta equals to 1 over 6 pi. So gradient basically means dy by dx. Agreed? Dy by dx can also be written as dy by d theta over dx by d theta. Agreed? Because when the d theta cancel, I'll get dy by dx again. So what I'll do is I'll calculate my dy by d theta, which is basically differentiating this. So the differentiation of 1 is 0. The differentiation of tan is sec square. So I can write this as 2 into sec square 2 theta multiplied by the differentiation of 2 theta, which is simply 2. So I can write this basically as 4 sec square 2 theta. Got it? Now I have dx by d theta. Agreed? So dx by d theta is a differentiation for this. The differentiation of sine is cos. Agreed? So I can write this as 3 into cos 2 theta into the differentiation of 2 theta, okay, which is 2 because of chain rule. So I'll simply get 6 cos 2 theta. Got it? So now I need dy by d theta over dx by d theta, correct? So my dy by dx will basically be equal to 4 sec square 2 theta over 6 cos 2 theta. So I can basically write this as dy by dx. I know sec square is basically 1 over cos. Agreed? So I can basically write this as 2 over 3 into cos square 2 theta into cos 2 theta, which can basically be written as dy by dx equals to 2 over 3 cos cube 2 theta. So now what I simply need to do is, because I need the gradient, in the place of theta, I can simply put 1 over 6 pi. So I can write this as 2 over 3 cos cube 2 into 1 over 6 pi. Okay? So you can simply, solve this on the calci, even I'm doing it. Okay? So this is basically 1 over 6 pi. Make sure you're on the radian mode, okay? Because if you're on the degree mode, you won't get the correct answer. Okay, so just make sure you are on the radian mode. Yeah. Now when you click on equal to, you get your dy by dx as 16 over 3, which is the final answer of the question. Okay, the exact gradient. Now, find the value of theta at the point where the gradient of the curve is 2, giving the value correct to 3 significant figures. Okay, so what you basically need to do here is, your dy by dx from the above part, your dy by dx is equal to simply, you can take, let's say this, okay, 2 over 3 cos cube 2 theta. Okay, now you know your dy by dx, which is the gradient, is 2. So I can equate this to 2 equals to 2 over 3 cos cube 2 theta. Correct? So I can cut this here. Agreed? And I can basically write this as cos cube 2 theta equals to 1 over 3. Agreed? Which I can write as cos 2 theta equals to the cube root, okay, of 1 over 3. So I can write cos 2 theta. Okay, now I need my cos 2 theta to be positive. So I'll go on my ASTC curve here. Cos is positive simply here and here. Agreed? So but I know my domain, which is 0 to 1 over 4 pi. But still, you calculate for both the quadrants and then we can eliminate one value. So 2 theta will be equal to, okay, so on your calc do cos inverse of the cube root of 1 over 3. So when you do that, you get your answer as 0.80465, and this is for the first quadrant. For the last quadrant, I do 360 minus theta, or in this case, because it's radian, I do 2 pi minus theta, and theta is the value of the positive quadrant. So I'll simply do, okay, 2 pi minus 0.880465. So when I do that, I get my answer as 5.4785. So now I can simply write this theta equals to, I can simply do 0.80465, okay, which is divided by 2. So I get 0.4023, okay, and I know 5.4785 divided by 2, okay, gives me 2.739. But now if you see, okay, your domain is 0 to 1 over 4 pi. That means if you see, 2.739 does not lie in the domain. So you can simply cancel this off. So your final answer is basically theta equals to 0.402, which is basically the final answer of your question.